40 meters beneath the ocean, 76,000 tons of concrete are being lowered into total darkness. A mistake of just a few millimeters and 3,000 workers would drown instantly. But when you discover what they were building down there and why, you'll understand why American engineers called it technically impossible. Decades ago, China couldn't even build a decent bridge without foreign help. Engineers around the world laughed when the Chinese spoke about megaprojects. But something changed, something radical. Today, while developed countries debate budgets to repair highways, China is building underwater tunnels so deep they seem to break the laws of physics. Bridges so long they can be seen from space. Rail networks so vast they surpass the rest of the world combined. And the most astonishing part, they're building all of this in months, not decades. How did a nation that once had to copy basic technology transform into the greatest infrastructure giant humanity has ever seen? The answer will challenge everything you think you know about modern engineering. There's an old Chinese saying that explains this obsession with infrastructure. If you want to get rich, build roads first. It sounds simple, but it holds a brutal truth about economic development. Transportation isn't a luxury. It's the backbone of any civilization that wants to prosper. People and goods must move. Without that, the economy stops, and China understood this better than any other nation in modern history. While Western powers were debating environmental impact reports, China was building the future, and the numbers are staggering. In just one decade, China built and put into operation 45,000 kilometers of high-speed rail. Japan and Europe, pioneers of this technology, took 3 times longer to develop their networks. And even then, their scale is only a fraction of what China has achieved. Today, China's high-speed rail network alone surpasses all other countries in the world combined. But it's not just about quantity, it's about revolutionary quality. China didn't just copy foreign technology, it mastered it, perfected it, and now leads the 4.0 era of high-speed trains. Speeds once considered theoretically impossible are now routine. While developed nations struggle to maintain their aging railways, China is redefining what land transportation means. Railways already impress, but bridges that connect entire islands to the mainland prepare for visual impact. From space, you're about to witness one of the most daring feats of engineering ever conceived, the Shihomen Bridge, the world's largest island-to-mainland connection. Its main span of 1,050 meters leaps across the ocean in a single stretch. For 10 consecutive years, it held the record as China's longest span bridge. But that's only the beginning. Along with the Jintang Taoyaomen, Xiangmen, and Shengxi bridges, a chain of mega-bridges extends nearly 50 kilometers, uniting once isolated islands into a continuous territory. 9 years later came the Yushan Bridge, 8 kilometers long, connecting Yushan Island to Daishan Island. 12 years later, the Zhoushan-Daishan Bridge, 25 kilometers long, linked Daishan to Zhoushan, the main island. Add to that the Donghai Bridge, stretching 32.5 kilometers and connecting Shanghai to Yangshan Island, and the Luheng Road Bridge still under construction. The result, China gained the busiest cargo port in the world, the second largest offshore green petrochemical base, and its first major fishing territory. This isn't simply a bridge, it's a super connection that reshaped China's coastline and redefined what's possible in modern engineering. But if you think bridges over the sea are impressive, wait until you see what they're building under the ocean. After mastering ocean-spanning bridges, China aimed for an even greater challenge: high-speed rail tunnels beneath the sea. Welcome to the Jintang Undersea Tunnel, a 18 kilometers in total length, with 11.21 kilometers excavated beneath the seabed. Its cross-section measures 14.5 meters in diameter, as tall as a 5-story building, large enough to hold dual high-speed train tracks. Construction depends on a colossal tunnel boring machine called Dinghai. Its cutter head is nearly 15 meters in diameter, with steel blades that act like the fangs of a giant beast, slicing through layers of rock and soil. Guided with millimeter precision by China's Beidou satellite navigation system, it advances toward another machine, Yongzhou, coming from the opposite direction. Deep under the seabed, the two machines finally meet with a precision of just a few millimeters. The tunnel runs 78 meters below sea level, where the boring machines must withstand monstrous water pressure. And precision is everything. In an undersea tunnel, even the smallest manual measurement error multiplies with distance. A miscalculation, and you end up with two separate tunnels instead of one. To prevent disaster, engineers deployed 6 Beidou satellites connected to the machine's automatic navigation systems, correcting deviations in real time. In the end, the alignment error was kept within just 2 centimeters. Then came the final challenge: how to remove the machines. When two titans meet underground, there's no exit ahead and no way back. The solution: a technique called peeling the shell. The tunnel boring machines are dismantled piece by piece and removed while their massive steel casings remain inside the tunnel, permanently reinforcing its structure. According to the schedule, the Jintang undersea tunnel will be fully excavated by the end of 2026 and open to traffic with the Zhoushan-Ningbo Railway in 2028. Once complete, passengers will travel from Ningbo to Zhoushan in just 30 minutes by high-speed train, ending the island's long history of isolation. High-speed undersea tunnels are already otherworldly, but building tunnels 40 meters below the ocean using 76,000-ton concrete tubes defies gravity itself. Here's the billion-dollar question. The ocean is full of water, so how do you build a tunnel beneath the seabed? And how did Chinese engineers manage to construct a 6.7-kilometer undersea tunnel 40 meters deep? At first, engineers considered using tunnel boring machines, but since these require extreme stability, the tunnels they dug would have been much deeper than required. They needed another solution. The goal: build a massive ocean bridge connecting Hong Kong, Zhuhai, and Macau, a project now hailed as one of the 7 wonders of the modern world. The final solution was immersed tube technology. In this method, trenches are dredged into the seabed. Prefabricated concrete tunnel sections called immersed tubes are lowered into these trenches, aligned underwater, joined together, and finally covered with sand and gravel. Each tunnel section is 180 meters long and weighs 70,000 tons, roughly the same as an aircraft carrier. Each contains 2 3-lane roadways and 2 service tunnels. Chinese engineers had to lower and align these massive tubes one by one, but fabricating a single 180-meter-long, 76,000-ton reinforced concrete unit was almost impossible. The solution: divide each section into 8 smaller parts, prefabricate them in a factory, and then assemble them into one complete 180-meter unit. On the uninhabited Niutu Island, more than 3,000 workers built a massive factory in just 100 days. Its only purpose: to produce the 33 immersed tubes required at a rate of 2 per month, each weighing 76,000 tons. After more than 400 days of construction, almost all tunnel sections were in place. Once the final segment was sealed, the Hong Kong-Zhuhai-Macau Bridge undersea tunnel, which stunned the world, was complete. From ocean bridges to undersea tunnels, from vast high-speed rail networks to colossal hydroelectric projects, China continues to redefine the limits of human engineering. These aren't just structures of steel and concrete. They're symbols of ambition, vision, and determination. Of course, such projects spark global debate. Some marvel at China's speed and precision. Others question the social and environmental costs. But one thing is undeniable: China has shown the world that the future isn't something you wait for, it's something you build. So what do you think? Are China's megaprojects a new chapter in human civilization, or a massive gamble that could backfire? Share your thoughts in the comments below. China has repeatedly pushed the boundaries of human engineering. These projects aren't just transforming China, they're reshaping the world.